Welcome to this explainer. Have you ever actually stopped to think about what connects, say, a car just cruising past your window to the massive planet silently revolving out there in deep space? Well, it's motion. Today, we're going to unpack this ultimate foundation of physics. It's really the hidden rule of our moving world, and I'm honestly thrilled to guide you through exactly how it all works.
Here is our roadmap for today. We'll start with what actually is motion. Then, the secret of reference points. After that, how things move. Measuring the movement, visualizing and predicting motion, and finally, we'll wrap up with the moving universe. Let's get right into it.
Okay, let's dive into this. Section 1. What actually is motion? The basics of movement. I want you to just picture a really simple scenario. Imagine you're standing on a railway platform. A train approaches you, rushes past the platform, and then completely disappears into the distance. So what exactly just happened from a purely scientific perspective?
Well, the answer is incredibly elegant in its simplicity. The train changed its position with time. That's it. That basic change in position over time is the absolute essence of motion. And it's a phenomenon happening everywhere, literally every single second, whether it's a kid running across a playground or water flowing down a river.
Let's officially lock in the definition here. Motion is the change in position of an object with respect to a reference point over a period of time. So the absolutely crucial thing to remember is that motion requires three distinct elements to exist. First, position, where the object actually is. Second, time, when the change happened. And third, the actual physical change in that location.
Section 2. The secret of reference points. The illusion of stillness. To truly understand motion, we kind of have to flip our perspective. Imagine you're sitting inside a moving bus. Now, relative to the passenger sitting right next to you, you are completely at rest, right? But relative to a person standing outside on the road, you are hurtling forward. And this brings us to a massive aha moment in physics. Stillness, it's often a total illusion. This is what we call relative motion, the concept that the state of motion depends entirely on the observer's reference point. Whether you are moving or resting is totally relative to your chosen anchor. Let's move to and see how this builds. Section 3. How things move. Categorizing the physics. Physicists actually organize the study of motion neatly into two major branches. First up, we've got kinematics. This describes the how. It studies motion without worrying about the underlying causes, so it focuses purely on things like distance, speed, and time. Then we have dynamics. This explains the why. Dynamics studies motion along with the actual physical forces responsible for it, bringing in concepts like mass and Newton's laws. Now, when we look at the physical paths that objects take, we can rapidly categorize them. Rectilinear motion is just walking in a straight line. Curvilinear, think of a thrown ball following a curved path. Circular is like the Earth moving around the sun. Rotational is a ceiling fan spinning on its axis. And finally, oscillatory is the repeated back and forth movement, like a swinging pendulum. Section 4. Measuring the movement. The language of physics. Here's a really fascinating contrast for you. Distance is the total path traveled, while displacement is the shortest distance between your initial and final position, including a specific direction. So think about it like this. If you walk 5 meters east, and then you turn around and walk 5 meters west, right back to exactly where you started, your distance traveled is 10 meters. But your displacement? It is absolutely 0. That exact same logic applies to speed versus velocity. Speed is just the distance traveled per unit of time. Velocity, on the other hand, is the displacement traveled per unit of time. Velocity is special because it strictly requires a specific direction.
But what happens when that velocity speeds up, slows down, or changes direction? Well, then we get acceleration. It's formally defined as the rate of change of velocity with time.
We can kind of sum up these measurements by splitting them into two types of physical quantities. A scalar quantity has only magnitude, stuff like speed and distance. A vector quantity, however, has magnitude and direction, like velocity and acceleration. It's wild, but the simple addition of that one word, direction, changes the math completely.
Section 5. Visualizing and predicting motion, graphs and equations.
To actually understand motion visually, physicists rely heavily on three specific tools: distance time, velocity time, and acceleration time graphs. By plotting data on these, we can instantly visualize trends and calculate speed, velocity, and distance traveled literally at a single glance, without getting completely lost in the numbers.
And this brilliantly illustrates how we handle constant acceleration. We rely on three fundamental equations. By mathematically relating velocity, time, and distance, these specific formulas allow us to predict exactly where a moving object is going to be in the future, or exactly how fast it'll be going. It's almost like having a crystal ball for physics.
Section 6. The Moving Universe. Physics in Action.
You know, you might feel perfectly stationary watching this explainer right now, but I promise you, you are absolutely not. The Earth beneath you is rotating at roughly 1,000 miles per hour. Rockets are traveling thousands of kilometers an hour right above us. The tiny atoms inside the very screen you're looking at are continuously vibrating. And on a truly massive scale, entire galaxies are hurtling through space right this second.
There's a quote that perfectly captures the essence of our source material today. Whenever you see a moving car, a flying bird, a rotating fan, or even the rising sun, remember, you are witnessing physics in action. I just love that. Motion isn't just some dry textbook subject, it is the vibrant heartbeat of our reality.
As we wrap up this explainer, remember that motion is the very language through which the universe operates. So I want to leave you with this provocative thought. Take a second, look around your room right now. What hidden rules of motion are you witnessing at this very second? Keep observing and keep learning.